Hey guys, 4.1. Okay, the ideas of 4.1 that we need to understand is the big ideas are we are going to mainly simplify radicals, which is just a fancy way of saying we are going to simplify roots, okay, by hand, not using a calculator, okay? And that's day one. This part that says rationalizing the denominator, that is not going to happen. And then we are going to day two, this is day two, is perform operations. So the first day alone is just simplifying roots by hand. So 4.1a says using properties of radicals. A radical expression is an expression that contains a radical. This is also a root. Okay? An expression involving a radical with the index n in the simplest form when these three conditions are met. Okay? No radicands. Radicand is inside. No insides have perfect nth power as factors other than 1. Meaning you don't, if there's square roots in there, you don't have squares in there. If there's cube roots in there, if it's a cube root, you don't have cubes in there, okay? No radicand contains fractions, so no fractions, okay? And then no radicals appear in the bottom. But the main one we're going to focus on today is we're going to focus on this one, okay? And basically what it means is the way we're going to do it, this says that there's a product property of square roots, but we're going to focus on the fact that we are going to make factor trees. So that's what I want you to write here, factor tree. Okay, and you're going to make a factor tree and you're going to circle in groups of n. Okay, so if I'm going to simplify this root, 108, I'm going to factor tree it. And this is where knowing your times tables is super important, but if not, you can grab a calculator. So for example, in this one, I might not know what multiplies to 108, but I do know that 108 is even, so it's divisible by 2. So I'm going to make my factor tree, and I have 2 and 54. Then I'm going to break up 54, and I know 54 is 6 times 9, and 9 is 3, and 3, and 6 is 2, and 3. So since this is a square root, n equals 2, so I'm going to look for buddies. Okay, I'm going to look for partners, and there's a group of 2, and there's a group of 2. So if I circle them in a group of 2, they get to come outside of the root. So I have a 2, I'm going to multiply it by the 3, because the 3 comes out. And then left inside is this 3. So this simplifies to 6 square roots of 3. Okay? Because the root size is 2, I'm going to take out buddies, or perfect squares, and leave in people, or numbers, not people, leave in numbers that do not have a buddy. Okay? This next one, example B. Same thing, we're going to make a factor tree. 9 is 3 times 3, and x cubed is x times x times x. Because this is root 2, I'm going to circle them in buddies. So a 3 comes out, an x comes out, and then you've got an x that stays inside. Okay? Do me a favor. Pause the video. I want you to see how far you can get on your own. Okay? 1 through 4. And then hop back and I'm going to do all of them. Okay? Okay, hopefully you paused. And someone's going to ask this, they're going to say, Miss Bustle, does it matter how you break it up? It doesn't, as long as your multiplication is right. Okay, as long as you're not making up your own times tables, it doesn't matter. So like 24 can be 3 times 8 or 4 times 6. No matter what, if you go all the way down to the very end, you're going to get to the same spot. So when I think of 24, I think of 4 and 6, and 4 is 2 and 2, and 6 is 2 and 3. Because this is root size 2, I've got one group of 2's that come out, and on the inside I have a 2 and a 3. So the best simplified answer is 2 square roots of 6. So I'm taking them apart with division, and I put things back together through multiplication. Okay? Hold up. Okay, number 2. the process is the same. There's a negative sign out front, but that doesn't matter. We're just gonna, whatever we take out is gonna be negative. So 80 is 8 and 10, and 8 is 2 times 4, and 4 is 2 times 2, and then 10 is 2 times 5. Square root, I'm looking for buddies. So I bring out a 2 and a 2, and this 5 is left inside, and then there's a negative that I start with. So this is negative 4 square roots of 5. Whatever is out front, we just multiply to what we take out. So 49 is 7 times 7. There's a group. Then I have x, x, x. I can have one group, so I have a 7 and an x, and then inside is just one x left over. Okay, then the next one, the 75 and n to the 5th. 75, you might not know, but I know that 75 is 3/4. 75 cents is 3/4, and 25 is 5 and 5. So the 5s get to come out. And then I get to do the ends. And in buddies, I get two groups of n. So I have a 5, an n, an n, and then inside, you still have the 3 and this n. So the best answer is 5n squared square root of 3n.